langchaincommunity vectorstores VikingDB VikingDB config. Definition: a configuration class used for establishing a connection with the VikingDB database and defining the parameters for interaction with it. This class acts as a bridge between the vector store and VikingDB, enabling efficient storage and retrieval of embeddings and related text data. Components. Component 1. The host address of the VikingDB server. Either a hostname or an Internet Protocol IP address. It specifies the location of the database server where the vector store will connect and store its data. For example, if the VikingDB server is accessible at dbserver.example.com, this would be the value for the host parameter. Component 2. The port number on the VikingDB server where the vector store should establish a connection. This port is dedicated for communication between the vector store and the VikingDB server. For example, if the VikingDB server is listening on port 5432, this would be the value for the port parameter. Component 3. The name of the specific VikingDB database where the vector store will store and retrieve its data. A database is a collection of tables and other objects that hold data related to a particular domain. For instance, if the vector store is used for storing information about articles, the database name might be articles.db. Component 4. The username used to authenticate with the VikingDB server. This username is associated with an account on the server that has specific privileges for accessing the database. It acts as an identifier to verify the identity of the vector store connecting to the server. For example, the username might be admin for a general administrative account or vector store user for a dedicated account for the vector store. Component 5. The password associated with the username used for authentication with the VikingDB server. This password ensures that only authorized users or applications can access the database. It acts as a security measure to protect the data stored in the database from unauthorized access. Passwords should be kept confidential and not shared. Component 6. The name of the table within the VikingDB database where the embeddings will be stored. A table is a structured collection of data organized into rows and columns. This parameter specifies the specific location within the database where the vector store will store its embeddings. For example, the table name might be embeddings or document vectors. Component 7. The name of the column within the table designated to store the embeddings. A column represents a specific characteristic or attribute of the data stored in the table. This parameter specifies the column where the vector representations of the text data will be stored. For example, the column name might be embedding vector or embedding array. Component 8. The name of the column in the table where the original text associated with the embeddings will be stored. This column allows for retrieving the original text corresponding to a given embedding. For example, the column name might be text or document content. Component 9. The name of the column in the table that will store the document IDs. Document IDs are unique identifiers assigned to each document in the collection, enabling the vector store to keep track of individual documents and their associated data. This parameter specifies the column where these IDs will be stored. For example, the column name might be document ID or ID. Component 10. The connection string used to establish a connection with the VikingDB server. This string encapsulates all the necessary connection information, such as hostname, port, database name, username, and password. It acts as a single point of reference for defining the connection details. For example, The connection string might look like Postgres Cloud min password db server.example.com 5432 articles db. Component 11. The function responsible for converting text into numerical representations called embeddings. Embedding functions map textual data into vectors of numbers that capture the semantic meaning of the text. These embeddings are then stored in the database and used for similarity searches. For example, a common embedding function might be OpenAI's text embedding ADA 002 or sentence transformers. OLMPNet Base 2. Component 12. The number of documents processed in a single batch during operations like inserting or retrieving data. Batching helps optimize performance by processing multiple documents simultaneously instead of individually. For example, a batch size of 100 would mean that 100 documents are processed together at a time. Component 13. The maximum number of times the vector store will retry an operation if it fails. Retries help handle temporary network issues or other transient errors by attempting the operation again. A higher value for max retries might increase the resilience of the vector store, but could also lead to longer delays in case of persistent issues. Component 14. The delay, measured in seconds, between retry attempts. This delay provides a pause between retries to avoid overwhelming the system with requests. A longer delay might be appropriate in case of frequent failures to avoid putting excessive strain on the database or network. Architecture. VikingDB is a distributed, scalable database designed to manage and process large amounts of data. Its distributed nature allows data to be partitioned across multiple servers, enabling parallel processing and improved performance. This architecture is well suited for storing embeddings and text data, facilitating efficient retrieval and similarity search operations. Role. The VikingDB config class plays a crucial role in defining the parameters for interaction between the vector store and the VikingDB database. It specifies the connection details, data storage configurations, and other settings required for efficient operation. This class acts as a bridge, ensuring seamless communication and data transfer between the vector store and the database. Advantages. Advantage 1. VikingDB offers high performance and scalability, allowing for efficient storage and processing of large datasets. Its distributed architecture enables parallel processing, significantly reducing query times and improving overall performance. This advantage is particularly important for applications dealing with large amounts of data, such as those involving large language models or knowledge graph construction. Advantage 2. VikingDB is designed to be secure and reliable, ensuring the integrity and confidentiality of the data stored within it. It implements robust security mechanisms to prevent unauthorized access and data breaches. Its reliability is further enhanced by its distributed architecture, where data is replicated across multiple servers, providing redundancy and resilience in case of failures. Challenges. Challenge 1. Accessing VikingDB requires establishing a connection using a connection string, which includes sensitive information such as credentials, username, and password. Proper security measures should be implemented to protect these credentials from unauthorized access, potentially involving encryption or secure storage methods. Challenge 2. Efficient storage of embeddings and text data within VikingDB relies on careful planning in configuration of tables and columns. The chosen data structures and indexing strategies can significantly impact performance and search efficiency. It's crucial to ensure that the table and column configurations align with the specific requirements of the vector store and the nature of the data being stored. For example, using appropriate data types and indexes for the embedding columns can accelerate similarity search operations.